In this lesson, you will learn to solve radical equations. Now, what do we mean when we say radical equations? Does that mean some equation that's pretty difficult to solve? It's pretty radical? No, what we mean is an equation that has a radical in it. But not just an equation with a radical in it. More specifically, the variable must be in the radical. So for example, the square root of x equals 4 is a radical equation because the variable is inside of the radical. We have the square root of x. Whereas x times the square root of 5 equals 8 is not a radical equation because the variable is not inside of the radical. So when we say we're going to learn how to solve radical equations, we are going to be solving something that looks like example 1, such as the square root of x equals 4. So how do you solve radical equations? So for example, here we have the square root of 2x minus 1 equals 3. When you have a radical equation where the variable is inside of the radical, first thing I want to do is isolate the radical term, which in this case has already been done for us. The radical is by itself on one side of the equation. But if it's not, make sure you isolate it first. And then you need to get rid of the radical by squaring, cubing, or something on both sides. And what we're going to do is we want to do the opposite of whatever's being done on the left side. So here we have a square root of 2x minus 1. So to get rid of a square root, I need to do the opposite of square rooting, which is squaring. So I'm going to square both sides. So when I square both sides, the square and the square root will undo each other, and I'm left with 2x minus 1 on the left side, and we have 3 squared, or 9, on the right side. So once you have gotten rid of the radical, we now have an equation that we can solve. So step 3 is solving for x. So if we add 1 to both sides, we get 2x equals 10. And so then 2x equals 10. Divide both sides by 2, x would be 5. So we have now solved a radical equation. But always take a moment and do step 4, which is double checking your answer by plugging it back in to the original equation. So for example, if we plugged a 5 back in for x, we would have the square root of 2 times 5 minus 1 equals 3. Well, the square root of 2 times 5 minus 1, that would give you 10 minus 1, or 9. The square root of 9 equals 3. That works. So our answer does check, but always take a moment and just make sure that you have the correct solution. Here's another example where now we have a cube root. So remember, step 1 is isolate the radical term. So to isolate, I need to add 1 to both sides. So step 1 is isolate. We add 1 to both sides. We now have 2 times the cube root of x equals 4. Step 2, now we've isolated, we can raise both sides of the equation to some power. In this case, we have a cube root, so we are going to cube both sides. Because when you cube both sides, the cube and the cube root will cancel each other, and the cube also goes with the 2 as well. So it goes with the 2 and the cube root of x. So what we have is 2 cubed, which is 8 times x, equals 4 cubed, which is 64. And then you can do step 3, which is solving. Divide both sides by 8. You get x equals 8. Then always double check to make sure that you have the correct solution. You plug an 8 back in. 2 times the cube root of 8. Well, the cube root of 8 would be 2, so 2 times 2 is 4. 4 minus 1 is 3. That would work. So that is the steps you want to use when solving radical equations. I'm going to show you one more example. So here we have 3x minus 5 square root of x equals 2. And we want to solve this equation for x. So one way we can do this is using the steps that we just showed you, where you can isolate the radical term first. So to do that, I need to get rid of this 3x. I need to move that out of the way by subtracting from both sides. So when I do that, I now have negative 5 times the square root of x equals 2 minus 3x. Okay, so then from here, once we have isolated, we can then proceed to step 2, which is raising both sides to some power. Well, we have a square root over here, so to get rid of the square root, I need to do the opposite of square rooting, which is going to be squaring. So I square both sides completely. Now take note, when I square the right side, I'm squaring the entire quantity of 2 minus 3x. So, on the left side, negative 5 squared would give me a 25, and the square root of x squared, that would cancel each other out. I'm left with just an x. And then on the right side, we have 2 minus 3x times 2 minus 3x. So on the right side, when you multiply 2 minus 3x times 2 minus 3x, I can then distribute 2 times 2, 2 times minus 3x, gives me 4 minus 6x, and then do the same thing again, negative 3x times 2, and then negative 3x times negative 3x gives you a positive 9x squared. So then I can combine like terms, and when I combine like terms, I have negative 6x minus 6x gives me a negative 12x. Now notice we have a quadratic equation. And what I like to do is set this equal to 0 and see if I can factor this. So to get this equal to 0, I want to subtract the 25x over. So now we have 0 on this side, and then we have 9x squared. Negative 12 minus 25 gives you negative 37x, and then you have the 4 over there. So I subtracted and changed the order so that it's now in descending order. We have the squared term, then the first power, then the one without the variable. So from here, we'd like to try to solve for x. So to solve for x in this case, because the coefficient with the x squared term is greater than 1, it's a 9, to factor, what I need to do is take the 9 times the 4 to get 36, and I'll do that right here. And then we ask, how do we get to 36? What multiplies to get 36? Well, it could be 1 and 36, could be 2 and, that's 36, okay. 2 and 18, could be 3 and 12, could be 4 and 9, or 6 and 6. Or it could be both negative as well, so you have negative for each of those. Well, we want to try to add those together to get negative 37 back out. Well, if we had negative 1 and negative 36 right here, those would add up to be negative 37. Those would multiply to give you a positive 36. So what I want to do is use those and replace negative 37x with instead negative 1x minus 36x. And so we have 9x squared and then plus 4 still as well. Now from here, I can factor by grouping. So if I group together the first two and then the last two, just take note that this minus sign outside of the parentheses will change this from a positive into a negative. Okay, so now what I want to do is I want to pull out the greatest common factor from each set of terms. So for the first group here, I can pull out an x, and they are left with a 9x minus 1. And then over here, we can pull out a 4, and we're left with a 9x minus 1 as well. And then we can combine, or pull out, sorry, the 9x minus 1, because those are in common. And then I'm left with an x minus 4 over here in parentheses. And by the way, that's all still equal to 0. So we have factored, and now to solve for x, we can set each part equal to 0. Where either 9x minus 1 equals 0, or x minus 4 equals 0. And then I can solve this one by adding 1. We get 9x equals 1, and then divide both sides by 9. So now we have x equals 1 over 9. Or, over here we can add 4 to both sides, and we're going to get x equals 4. So x equals 1/9 or x equals 4 would be my solution. But remember, as we said, always double check to make sure that we have the correct solution. And in this case, one of these answers will not work. It will not be correct. Even though we went through all the steps and we got these two solutions, there are cases when one of them will not actually work. So we want to double check by plugging in the 1/9 and the 4 back in to my original equation in for x. So looking here, we can plug a 1/9 in, and we get 3 times 1/9 minus 5 times the square root of 1/9 equals 2. So in place of x, I'm going to put in a 1/9. Well, 3 times 1/9 would be 3/9 or 1/3, and then the square root of 1/9 would be the square root of 1 over the square root of 9, which would be also 1/3. So here we have 1/3 minus 5 times 1/3, which would be 5/3, and 1 minus 5/3 would give me a negative 4/3. Sorry, negative 4/3. And notice that is not equal to 2, so therefore that is not a solution. But if we were to check the 4, we have 3 times 4 minus 5 times the square root of 4. We'd have 12 minus 5 times 2, and 12 minus 10 would equal 2. So 2 equals 2. This would be a solution. So in this case in particular, there's only one solution, even though the work showed that it appears to have 2, but there's only one in fact. And that concludes our lesson for today. We will see you next time.